I want to talk to you today about mobile application testing and development using Appium, Espresso, XCUITest. And there's going to be some times when I refer to Espresso and XCUITest interchangeably. They're not interchangeable, but the way they work philosophically is very similar. And I think the approach to choosing Espresso or XCUITest would be very similar uh, between those two platforms as opposed to as an alternative to Appium. So if you choose Appium, you're getting one thing. And if you choose Espresso or XCUI, you're generally getting exactly the same thing, depending on if it's Android or iOS. So that's what I intend to talk about mostly today. And I'll go into a little bit of detail, but mostly I'm going to cover pros, cons, when you would do which, when you would choose what, the different considerations, because neither is better than the other. There's just a bunch of different choices you have to make. And it's something that you should have an educated mindset on before you make the choice, because you're getting trade-offs whichever choice you make. So without further ado, I'll go into so today what I want to talk about is the different types of mobile apps that exist in the world. I also want to talk about Appium itself, the architecture of native frameworks that you would use for testing, and then the trade-offs and the pros, cons, what you should not do. Also give a link to resources. The truth is that I think there are 50 or 60 slides in this deck. About 80% of it was prepared by my colleague, Wim Sellis. And I just added a few things to it, but mostly the intent was to give you kind of a survey of the overall topics. And then this slide deck, once we send it out, has 30 or 40 additional slides of super great detail about things like locator strategies and gesture automation, which I could talk about a little bit, but I'm not super educated on that stuff. Mostly I've used these things from a testing perspective and not a development perspective. So it'll be interesting if you can have a look at these resources that we're sending along with everything and see if you get any value out of that as well. Okay. Also, I would like to encourage people to chat in the Zoom chat. I'm going to try to make this a little bit interactive and ask questions and see if you can provide me some answers. I see Mike Milgate in there. He's awesome. So I think I'd love to see some interaction here. Hopefully I'll ask you some questions and you'll be able to jazz it up a little bit. So as Alyssa said, my name is Marcus Merrell. I'm the Senior Director of Field Services here at SOS. I've been here almost 2 years. I came to SOS Labs because after a nearly 20-year career in quality assurance, I decided that I wanted a little bit of a change in scenery. If you've automated the frameworks for 5 different companies and you've done it pretty well, the choice is, do you want to go and do a 6th, or do you want to go try to teach the world what you know? And it's funny, my wife said, those who can't do teach, which honestly I think is not a very great outlook. But I think to me, in my case, it was those who have done and are a little bit maybe overdone. They also can teach, and I think that's the way I look at this. So yeah, I'm the chair of the Selenium Conference Organizing Committee. I'm also the member of the steering committee for the project itself. And my life revolves around family, music, and making robots. I like to make things light up and move. And it's interesting, when we get to the slide where we feature Jason Huggins, I will have to stop myself from telling really long stories about Jason's involvement in robotics and how it's essentially effectively changed my life. I will try to keep that to about a 45-second story. So let's talk about the types of mobile apps that you have available to you. There's different ways to develop mobile apps, and it depends on where your team is coming from, where they're going, who is on the team, what your timelines are, what your tech stack is. All these things go into deciding what kind of app you choose to deliver. And so the most obvious that I think most people work on is native apps. So a native application, meaning it's natively running on the hardware using no intermediary layers between the software and the hardware. It's all running straight there on the iron with hardware that is purpose built to execute the functionality of the application. So if you're using a natively built application, you wrote it using Objective-C or Swift, you deployed it to an iPhone, and all of the calls inside there are working natively within the application. That's as opposed to a web application, which is same as any web application, but you account for a different window size, display size, when you are writing the code itself. But you use the same code that you would use to write anything, any web app. So you could use a Java stack, you could use HTML, CSS, JavaScript, you could use React, you could use anything you would like in order to create the same thing you use to create a web app would be used to create a web app on a mobile device. It just means that the mobile device is using Chrome or Safari to go to a web page, render the page, make it as interactive as any web page, but then it is still going through this layer of Safari or Chrome in order to utilize the iron, the native hardware inside the application. There's this abstraction layer between the web and the device, as opposed to a native app, which is directly using the device's features. A hybrid app is a view between the two. So a native app is the one that uses the iron directly, but there is a native app where you can provide a window within the native application that looks at a web page. And these are becoming more popular, although I think it's starting to taper off a little bit. But it allows the developers the flexibility to be able to release changes to the code without shipping a new version of the app. So if you've ever had an application update at a inconvenient time, or it's not doing what you want it to do and they have to deploy an update in order to make it work properly, a hybrid app lets you get around that by providing a web view and fundamentally change the web application functionality from the server side, not from the client side. So you don't have to deploy a new change in order to make this happen. If there's any questions, please let me know. But these are the main three. There's also a framework that can be used to develop front-end applications called React Native, which is kind of a hybrid where you can use React, the same framework that you would normally use to develop a web application. You can use that will translate native calls underneath, that allows you to approach a native app the same way you'd approach a web app, but without having to learn all the intricacies of Objective-C, Swift, Kotlin, Java, those kinds of things. So on the left is an iOS app, on the right is an Android app. I'm sure everyone in the audience knows roughly kind of the difference between the two platforms. There's an interesting story that I think I can get into a little bit in advance of talking about Appium, which is that Appium was partially invented because there was a belief in 2012, 2013, that when you develop an iOS or an Android app, you're roughly going to be developing the same app on both. You have an app, it has the same number of pages, it has the same data, same readout, same navigation flow, and you deploy to both Android and iOS. And then Appium has the promise of being able to allow you to write the same test code, and then it would translate to the same tests being executed on Android and iOS. And we all believed at the time that this was going to be the future of testing. Why even do anything else? And then it wasn't long, 2014, 2015, that studies started to show that Android and iOS users fundamentally differed in how they expect an app to work and how it should function and how the navigation trees should work and the kind of idiomatic use of the device that you have. Now, having said that, I don't have any studies to cite, and I suddenly realized that's a little deficiency, but I think that these honestly weren't like real academic studies that were done to begin with. This is just anecdotally, we figured through analytics, at least at the company I worked for at the time, that their usage models were so different that we had to separate not only the developer teams, but the design teams in the apps themselves, because we were favoring iOS and delivering what turned out to be a lousy experience on Android as told to us by the analytics. So we ended up having to bifurcate and separate out iOS and Android design as well as implementation so that you wouldn't have a unified experience, which was unfortunate from an efficiency perspective, but it was what the users wanted. So right away, we found that one of the great promises of Appium was unfortunately not always going to be implemented. There are certain apps that still keep this together, apps where user experience maybe isn't the priority, where getting stuff done is the priority, like internal apps for a company where you have to use an internal app in order to manage some sort of data. The user experience isn't really thought of as being the priority there, so they do keep their code paths the same. But I just wanted to point out that fundamentally what we have found what I have at least seen in the analytics of previous companies I've worked at is that fundamentally iOS and Android is a different audience. I would love also to see in the chat if anyone has any opinions on that, because that might be a little bit of a controversial statement. At the moment, I stand behind it, but I'm always willing to be proven wrong. So let's talk about Appium. I am not going to read this to you. I'll give you 10 seconds. I'm just kidding. That sounded awkward when I said it. Anyway, it's open source. That's the main thing here. It's open source. It's maintained by a community of people. A community of people that, you know, they have names, they have lives, they have generally day jobs that mean that they have to work on this in their spare time. It's not unlike Selenium in that way. There isn't a company backing this software up. It is maintained by a loving community who desperately wants to solve this problem. It was invented originally by a gentleman named Dan Cuellar, who I believe works for Apple at this point. It was conceived of by Dan Cuellar, implemented initially by Jason Huggins. Now, Jason Huggins, once again, I'll avoid talking about this for 30 minutes, but he is also a founder of Sauce Labs. He is also the original inventor of Selenium. So very prolific genius. The interesting thing is that in 2013 in Boston, when Dan Cuellar was going to propose Appium, he was going to propose a lightning talk, but he didn't put his name on the list in time. So we, the program committee, almost cut him for time because we thought we had all these other people. It turns out we had time to squeeze it in, and he delivered a 5-minute presentation on his concept for something called Appium that would unify mobile testing under one code base. And we were all kind of blown away by it, but there was also a certain number of us, I think myself included, although maybe not, who were saying, come on, there's no way you're going to do that. Well, enter Jason Huggins, and within just a few weeks, he had a prototype that worked. And within just a few weeks after that, there was a community that surrounded it. And within a few weeks after that, I'm saying between mid-2013, 4 months later, I was probably using Appium, I think within that time frame, because it was so successful in its initial promise. It was very, very impressive how this thing got off the ground. And it spread like wildfire through the industry, which is great. I like hanging out with dreamers. I tend to be the realist in the room, and even though the world needs people like me, the world needs people like them a little bit more, because without them, we wouldn't have the ideas. So at the top left is Jonathan Lips, and he was also a longtime Sauce Labs employee, one of the primary maintainers of Appium. I believe he is still the project lead for the project. And he now runs his own consulting firm around the Appium project itself. I won't take the time to introduce everyone on these slides, but they're all great people, and they all have contributed lots and lots of blood, sweat, tears, and hours, mostly unpaid free time hours, to maintaining this thing. And once we start talking about the architecture of Appium, that's when you'll understand why it takes an entire community to maintain this kind of thing, because it's complicated. And they've done an amazing job of abstracting it and making it look easy, like every open source project should do. So here is a diagram, a model of what Appium execution looks like. So you start from your test script, and that can be running locally. It could be running on your CI/CD server. It could be running, you know, anywhere that is actually going to be the sort of the brain of the test itself, the thing that controls the flow of the test. That's where the script lives. That's the origin point. So you make a library call to an Appium client that's also sitting locally on your machine. So that could be in Java, JavaScript, Python, Ruby, C#, WebDriver IO, whatever you need. It will be transmitting a library call to Appium, which will translate it into W3C specification WebDriver code that will talk to the Appium server. And the server is going to be running on in the same like vicinity of the device itself that you're trying to test on. That will talk to another open source package called the XCUITest driver. And this is where XCUITest is an Apple-based set of commands that are used to execute commands on an iOS device. So Appium needs to translate from W3C into an XCUI driver. The example would be if you receive a command to enter text, the library call back up here will be in JavaScript. It'll be translated into JSON that is in the web, that conforms to the WebDriver standard, which will then be translated into an XCUI API call which will then be converted into JSON wire protocol to the WebDriver agent, which is then converted into an XCUITest command, which is an Apple-driven command, which is then executed on the device. Is that 7 steps? 1, 2, 3, 4, 5. 7 steps between you and the device you're testing on. Even if you're running locally, the same 7 steps occur every single time, and that's the key. Every single time you run a command, enter text, it goes through these 7 steps. And once the device responds, it responds all the way back through the loop, translates back down to the JavaScript layer where it does logs. Every single command goes through these 7 steps and all the way back. So my question for the audience, and I would love for you all to participate, where does Sauce Labs fit in between what 2 steps? I would love to hear an answer in the chat, or if you want to speak up, it doesn't matter to me. Where does the cloud fit, or where does the remote execution step take place in between the two steps? I'll give you all about 8 seconds. WebDriver agent. First 2 boxes. It's right here between the Appium client and the Appium server. So just to be clear, between the Appium client and the Appium server, if I'm running a test in Austin, Texas, and I want to connect to a cloud provider like Sauce Labs whose data center is in San Jose, the request goes 1,700 miles between the client and the server. And then it goes however far between the server and the other processing elements that are in between it and the device itself, which is probably very close. But that's the gap that takes place, and keeping in mind that it's every single time. Click this button, 1,700 miles there, 1,700 miles back to tell me it worked. And then, click next, enter text, whatever you do. And one thing that we found is that sometimes there are third-party wrappers around Appium. There are sometimes either companies or open source projects that try to make Appium easier to use. I've seen a lot of examples where people implement like a behavior-driven Cucumber implementation on top of Appium, or keyword-driven, or so anything like that, where it's translating from one to the other. Where inside the guts of the wrapper, they'll actually do things like, if you enter text, you enter your name into a text field. They'll actually separate each character out into a single request and send that 1,700 miles there, 1,700 miles back for every single character in the row. And they wonder, we all wonder, why does it take 4 minutes for a single test to execute? It's because this data is traveling an unbelievable amount of distance in order to make it there and back. If you run it locally, of course it's fast. It's all running on the same silicon. But if we run this between the Austin data, my Austin CI/CD server, and the San Jose data center, it takes a very long amount of time. So one thing that we're trying to do at Sauce is work with the other vendors who are trying to build these kinds of things, as well as the open source projects. And we're trying to communicate with them to figure out how to optimize the WebDriver calls that they make, or the Appium calls that they make, to reduce the number of round trips that this data has to go through. So let's talk about driver architecture. This is what the Appium team has to keep up with. The issue, one of the primary issues facing Appium, which is thankfully opaque to most users because the community has done such a fantastic job of maintaining this project, is they've abstracted all of the complexity that's below the Appium box here. They've abstracted all of this away from you so you don't have to know about it. But the problem is that when Android Studio introduces a change, or when iOS comes out with Xcode 14 or iOS version 14 without really telling anyone, Appium maintainers then have to react to that, learn the API, in a lot of cases learn the undocumented parts of the API, implement those back into Appium, and make sure it is able to translate well between the Appium layer and the native layer that's changed. And they've done a fantastic job of keeping up with this stuff. But it always just makes me wonder, is there a point at which we need to start mitigating this risk a little bit better. We've made a lot of strides to make contact with the Google and Apple developers behind these things. And I believe that there is a very good relationship at this point. But to me, it's nothing more really than a point of risk, but it is a point of risk, something that needs to be recognized by a team that's implementing a tool like Appium. So let's contrast this with XCUI and Espresso tests. With a native app execution, when you're running locally, actually either way, locally or on cloud, you upload your application, your debuggable application to the device itself, and then you upload a separate APK or IPA file to that same device that contains the tests themselves, compiled binary code that contains the tests. When you kick off the test execution, 100% of the operation takes place on the device locally. There's no round trip between an external server and the internal device itself. All of it takes place natively inside that same device on purpose-built hardware. When you're running this on, that's what it looks like locally. When you run it on SOS, it comes from your build agent, Austin, Texas, and then you upload your app and you upload the compiled tests. You use a configuration file or a set of command line options to specify the tunnel, the Sauce Labs tunnel, the devices that you would like to use, and the tests that you would like to run that are a part of that test bundle. You upload those all at the same time to Sauce Labs, or you refer to an external to the storage that's already, if you've already uploaded it, you can upload it separately from the execution. After you upload it within the Sauce Labs cloud, it does a matchmaking for the device, it finds the device, and then once it finds the device, it installs these apps, executes everything on that hardware, and then returns the results back to you. You're no longer synchronous in terms of running your commands on the device itself. And this is very compelling to me because I hesitate to say that Appium tests are flaky, because in my opinion, Appium tests are not flaky. It just takes a lot of engineering to make them run consistently. Now that might be equivocating or a little bit of euphemism on my part, but I do believe it's true because I've seen Appium implementations where 100% of the tests pass 100% of the time until there's an actual bug. I've seen it happen. It is possible. But the more hops you introduce between yourself and the device being tested, and the more points of risk you introduce in terms of network latency and just variables, the more you see that you have to do the engineering as opposed to just writing your test and having it natively execute on the app. I feel like at this point I'm showing a little bit of a bias, and that's not my intent because my experience is mostly with Espresso and XCUI, so I tend to favor it. But I do think, and as we'll see in the next slide, that that there is a very compelling set of reasons why you would choose Appium. So let's do some compare and contrast. Appium, you can use any language you want. Seriously, you can use, like I said, Java, JavaScript, Python, C#, Ruby. I believe people had written Go bindings, although they're not official at this point. You can use any language you want. And that means that if you're a Java developer and you want to run tests on an iOS device, you don't have to learn Swift. So if you're using JavaScript, you don't have to learn Kotlin in order to run a test on Android. Very, very compelling. In my opinion, probably the most compelling reason why you would choose Appium, because you can, I promise you, you can engineer your way around flaky tests in Appium. But you can't engineer your way into having to learn, or out of learning Swift or Objective-C if you want to run natively. If that is your choice and you have to play with the hand you're dealt, Appium is a very fun choice. The risk of Appium, like I said, is that it trails iOS and Xcode changes, Android UI Automator changes. Changes are made to the platform. Then there can be a gap of several days or weeks for the Appium team to implement those changes. Having spoken to the Appium team several times, this is not all that big a risk. This is usually a very minor set of inconveniences, and they are usually able to turn it around very quickly. That's the history we've seen. I am not aware of very many customers at Sauce who are burned by this very often, but I do like to keep it in mind as a risk. It's a point of risk. And my job is to inform people of risks. And my job as a QA tester is to inform about risk. So if we're putting risk on the board, this is one of the big risks, because there have definitely been significant and breaking changes introduced in the iOS toolchain, I think between 8 and 9 and between 11 and 12 in particular. So your mileage may vary, but that is the thing that I always like to keep in mind when choosing between Appium and native app. Native frameworks, by their very nature, unless there's a bungled release, which I've never seen on these platforms, unless there's a bungled release, these are always up to date. You update to the new Xcode, it works. Everything's fine. So once again, Appium, there's a 3,000-mile round trip. Now that's just my example between Austin and San Jose, but your mileage may vary, literally. 3,000-mile round trip on every single command. And you can't avoid that. There's a way you can avoid that. I'll spend 5 seconds talking about how you can avoid that. There is a way you can actually bundle up an entire Appium script into a single string of JavaScript, upload that all at once, and then execute it all on sauce. And it'll execute just like a native app in that it'll do all of the commands all at the same time. Not very good for debugging, but super, super fast. That's the only way I know of to avoid this problem with Appium. And yeah, native frameworks, oh, my bullets aren't aligned. They all execute on the device in the native hardware that is purpose-built for those tests. And the other thing is the one I referred to already, which is that if you're using a wrapper around Appium, you don't always have fine control over how Appium is optimized to run on the cloud. All of these tools run really well locally, but we found that they don't all run against sauce very well, or a cloud provider, any cloud provider. If an Appium third-party framework doesn't run well on sauce, there's a very, very, very good chance it will not run on any cloud provider, any cloud-based device, anywhere. Just because it's all about the number of commands that are sent and how the synchronous nature of how these commands are managed within the Appium device, the Appium server. And outside of the initial upload phase of the native app runner, performance is generally going to be the same locally versus on sauce. So you could actually do some amount of performance metrics gathering when you're running native apps on sauce, because you'll be able to get the timing information that you can rely on. There's no third party, there's no really long wait for all the network latency that could happen. So here's when you should and should not use Appium. If your test team uses a different tech stack from the app development team, you should use Appium, in my opinion. Because if you are a QA team, if you're a QA lead, and this has been my experience actually through most of my career. I'm a QA lead, and my team is made up of Java or JavaScript developers or experts. And the iOS team is writing Objective-C or Swift. Well, do I want to have everyone in my team go through a Unity course on Swift before they can write the most rudimentary Xcode test, and then not have them be able to write a test for Android? No, I would rather have them use the skill they already know, write the same test in Java or Appium, Java or Java for Android or iOS. And then if possible, and I have been able to do this before, you can build, and this is something that we could talk about offline because it's too much detail for the session I have planned, but you could build, in theory, an iOS page object model and an Android page object model. And you could have a meta layer of code that would allow you to use the same user-based actions like login, username, password. And that's the test. Underneath, you abstract away the details of how the app differs from iOS to Android and have it translate underneath that. And it would work beautifully. I've actually had quite a few customers implement it this way. And I've also had success in my personal career implementing this kind of Appium stack that is able to test both. It's harder than the initial promise that I referred to earlier, but it's still possible. If you prefer to keep your iOS and Android tests in the same language and tool chain as your tests, it's probably better to use Appium. Otherwise, you have to install some stuff on Buddy Build, some stuff on Maven, Jenkins, however, that kind of thing. If you can tolerate, and once again, I think I stress that you should identify the risk of the Xcode and Android breaking changes, because it's a virtual guarantee that those changes are going to come and they're going to be at the wrong time. They're going to be deployed right when you need them the most, and nothing will work. And that's the thing that I'm always trying to be cognizant of, is that risk. If you already have an extensive implementation of Appium, there's really no migrating from Appium to XCUI or Espresso. You can migrate the test concepts, but unless you wrote your tests, possibly between, if you're using Appium Java with Android, there's probably not too heavy a lift to get them into Espresso, but there probably is more than you would like. It's pretty much going to be a rewrite. So if you already have a huge stack of Appium tests, I'm not sure I can wholeheartedly recommend rewriting them, because that's pretty much what you'll have to do. So the other thing is closed box, black box testing. You can't really see inside the application or the app if you are running a native app on a device through Appium. Also, once again, network latency. It's a big deal. Sorry, I don't know what just happened. Sorry about that. I didn't animate this one. So native frameworks are good if you are a developer, an app developer, and you want to shift left. You don't want to learn a new tool. You don't want to learn a new language. You want to be able to learn how to read, write, maintain tests. You should use native framework. It's a no-brainer. Why in the world would you stick Appium in there when it's got this whole other tech stack that it was built upon? If you keep your test code in the same language as the app under test, or your org is embracing a shift left motion, it seems like native app is an obvious choice. And then transparent box testing would allow you to see inside the app and get to know the internals. You can write a lot of code within Android Studio that will allow, or iOS, to allow you to monitor the app or do anything like that while the application is running. You can see inside of it, you can monitor, you can look at device vitals, you can do anything you can if the device is just sitting on your desktop. And you can access anything within the Android API. You can look at the file system, you can do anything. So native frameworks on both sides let you see inside the device as it's operating, even when it's on the Sauce Labs cloud, because it's all just executing code within the application. So the rest of what I have here is pretty much best practices and details. So I think we should probably stop and ask for questions before I go into any of this, because this is a lot more detailed than what we would need. So I'll go to the question I see. Is it a wise decision to have different tech stack and test team from app development team? I always face a lot of problems if we maintain different stacks and put more complication on my automation. It's interesting. I think that my colleague Titus and I we both have the same story to tell, which is that our career is long enough at this point that we've made every mistake in the book. And early in my career, 10 years ago, I would have said, I don't care what the developers are doing. My team is going to stay on our own stack. We developed this automation. It worked beautifully. We're going to apply that same thing to the native apps over here. And turns out that that's not a great idea. If you really have a choice and you can start from scratch, I agree with you, Mohammed. It is not necessarily a wise decision to have a different tech stack between the apps and the testers. I do think that there are cases where you have to. I think it's necessary sometimes. It depends on the context, of course, but if you have the choice, personally, I would always prefer to develop in the same tech stack as the app team for a number of reasons, one of which would most be that you can shift left a lot more easily. In my opinion, if you're having trouble getting your developers to learn how to write tests, and in some cases I've seen this, they're not even writing unit tests, I strongly recommend bringing people into a workshop environment and teaching them how to write unit tests by example. Write some code, write some more code, now write unit tests to test that code, and then have someone else come along and make a change and watch the unit test break and see what you have to go through in order to fix them. All of those exercises will really make someone see the light and how important testing is at the unit level. And then by extrapolation, you can apply all of it to the integration and UI API level. And it's transformative both to your career, your confidence, as well as to your organization's ability to deliver software quickly. And running everything in the same software stack, to me, just reduces a whole bunch of the friction and the barriers that are caused by choosing different tech stacks, just because that's not the skill set I have. Well, it is a lot easier for Marcus to go learn JavaScript than it is for the future Marcus to have to maintain a separate Java stack from the JavaScript that's been developed by the application developers. I say that because I've lived it. It's horribly inconvenient. But if you have to, just try to make sure you're following all the best practices and keeping all the risks in mind. Is there any way to migrate tests from Appium to native frameworks if at some point in time we find out that Appium doesn't work for us? What I would say is, if you plan to migrate tests from Appium to native frameworks, I don't think as far as I know, there is no magic button that just says like push a button and you've converted. There's nothing like that. If somebody knows of something, please let me know. I can imagine that at some point, everything you do in Appium is translated to an XCUI or Espresso or an Android call inside the hardware. I can imagine doing some sort of log output or proxy that would generate code, but that is so much more difficult. What I would say is, if you at all think that at some point Appium's not going to work for you, fail fast, fail early, get it. If you think that's a possibility, start now to shift into the native app framework, because it's going to be, to me, if it's 1x unit of work to translate one test case, it doesn't scale. If there's 10 test cases, it's 10x work. If there's 100 test cases, it's 100x work. I could be wrong about that. It might be slightly good scale, like 100 test cases is 80x work, but it's not great. Hardly any of the code translates, especially if you're going from something like JavaScript to Swift. That's my opinion, and I would love to see if there's any more differing opinions on that. Let's see, are there any more questions?
Hey, Marcus, it's Alyssa. Looks like you have one more from Tyler on how to avoid test failures that are dependent on the UI. Do you see that one?
Yeah. It's funny, my glib quick answer is use the API, but that's a bad answer, I know. How to avoid test failures that are dependent on the UI. Most of the time it will pass, but sometimes it will fail because somehow it can't find the UI element anymore. Well, the rest of this slide deck is concerned with, well, a lot of it. Locator strategy, and this is what I don't have time to go into, unfortunately, but we'll be sending out this slide deck, and I think that we should probably try to include some links from our friend Wim Sellis, who works on my team as well. I just corrected a typo. This contains a lot of different locator strategies. There's a lot of different ways on iOS in particular to optimize your locator strategy. In fact, I have, he sent me a video that I'm unable to locate at the moment, and we're also running out of time. But it actually shows the comparison between using a CSS locator on a native iOS application as opposed to a class chain or a predicate on iOS, which makes a huge difference. So to me, if it can't find a UI element on iOS in particular, you have several other much more sophisticated ways of being able to locate an element using these more advanced predicate string, that's what it's called, using these more advanced search methods. And we've seen customers improve their test performance greatly because not only is it more reliable, it is also faster. And we have comparison videos somewhere. Wim has that online. So yeah, this deck that we're going to send out has a lot of detail, and hopefully it will be useful to you. A lot of stuff around device selection and things like that.